Alright, welcome to Codivate's 6th weekly presentation video. In this video, we'll be talking about inheritance. So let's get to it. So what is inheritance? Well, let's think about genetics. You might have learned this in science class, but if you take yourself as an example, let's say your eye color is black or brown. Usually your parents' eye color is brown. So your parents passed traits to you, right? Your eye color is brown because your parents' eye colors are brown. So you kind of inherit genes. Genes are certain characteristics of your parent, and they get passed down to the child, or the children. So inheritance in programming is kind of the same thing. You have a parent class, and the parent class passes its characteristics, and we'll talk about what those characteristics can be, but they pass those characteristics to the child, and the child can inherit those characteristics. So let's talk about the semantics and the syntax of it. So classes have attributes and methods, right? These are what define or build a class. So this provides the class special functionality, right, in your code. But you might come across some classes that have very similar functionalities, but they perform different tasks. For example, if we have a cat and a dog class in our code, let's say we're building a zoo, and we have a cat and a dog class, a cat and a dog would be quite similar, right? They both eat, sleep, play, and they do a lot of other things that are similar to animals in general, right? So creating two separate classes called a cat and a dog and implementing the same functions, same attributes and all that in both the classes will be sort of tedious. So this is where inheritance comes to the rescue. So in programming, you never want to repeat yourself. So the dry kind of ideology or the dry method, don't repeat yourself, is a very fundamental concept in programming. You never want to rewrite code if you don't have to. Inheritance allows you to minimize repetition by creating parent classes called more formally superclasses and child classes called more formally subclasses. And we'll talk more on that later. So let's look at this dog and cat's example. These two animals are quite similar, right? They can walk, they can sleep, they can talk, as in make a sound, or make a, they can make any type of sound that they usually make, like a dog would bark, a cat would meow, and they can have names, etc. So there are a lot of similarities between these two classes. If we create a dog class and a cat class, rewriting all this similar code is not that good. It's not recommended, at least. So what if we could define a more broader general animal class that has all the common information that these two classes, dog and cat, could have? Well, this is exactly what we want to do with inheritance. So let's create this animal class. So if you look back at this dog and cat class, they have a function called sleep, eat, and speak. Both of these have these functions, and our animal class has this function again. So this animal class has a single attribute called name, and this could be different between different instances of the object. Notice how an instance is just when you instantiate a class. So different instances of this animal object could have different names. And it also has the same functionality, sleep, eat, and speak. So this is a very simple class and provides some basic functionality for any pet. So dogs and cats are all pets, and this animal class provides the same functionality. So let's talk about the improved dog and cat class now. So these classes now look a lot smaller, right? We're not repeating a lot of stuff. So in our class dog, we'll notice how in the parentheses after the class name, we specify our animal class. Remember the class animal? And this is the actual syntax of inheritance. So whenever you want to inherit another class, you provide that class inside the parentheses after the class name. So in its case, class dog inherits animal, and class cat inherits animal. So we will break down each part more in detail in the future slides, but this is how we basically inherit a parent class. And the important thing to notice is at the bottom, when we call dog.speak, dog.eat, and dog.sleep, these are perfectly valid code. But you might be saying, oh, dog does not have an eat and a sleep function. So where is that coming from? Well, that's coming from animal class, right? So we're inheriting the characteristics of animal in our dog. So we're given access to the functions, the attributes, and all of the characteristics of the animal class within our dog. So if you look at the animal class, the speak and eat functions respectively say making arbitrary noises and then I'm hungry. So when we call dog.eat, we get I'm hungry. And when we get dog.sleep, or if I say, yeah, so the sleep function actually says self.name plus is sleeping. So in this case, we set the name to be Rover. So when we call dog.sleep, we get Rover is sleeping. So that's the basics of inheritance and how we can call methods that we might not have necessarily declared in our code, but come from the parent classes. So establishing inheritance. Animal in this case is called a superclass or the parent class. So if you hear parent class and superclass, they're both interchangeable. And dog is the child class or subclass. So just like parent and superclass, these two terms are interchangeable. But the formal declarations are superclass and subclass. So to create a subclass, you just create a normal class, except you tell Python what the parent class is going to be by providing that parent class within the parentheses. So if we have a class dog, we provide the parent class, which in this case we want to be animal, and we provide that through the parentheses of dog. So notice how the class animal, it does not require parentheses because we're not inheriting anything, but class dog requires parentheses because we're inheriting animal. So now dog has the sleep function, the eat function, the speak function, and all those characteristics like the name, self.name, it also has those attributes. And we don't have to explicitly define them in our class dog, which is kind of handy. So let's talk about overriding methods. We did show that in the previous screenshots if you didn't realize, but let's talk about overriding methods. In the animal class, notice how we have sleep, eat, and speak. In the dog class, we have our normal constructor, the init method, and we also have speak. So you can see how there could be some issues, right? If animal also defines speak and dog defines speak, how would Python know which one to use? Because we're inheriting animal, right? So how would Python know if we should use the speak in dog or speak in animal? Well, in Python, there's an order of lookups, and we'll talk about that in the future slide, but there's an order of lookups. But all you have to know right now is that this is overriding the function. So if you call dog.speak, since the speak function is clearly within the dog class, we go to that first. So calling eat, we don't have a function called eat in the dog class, so Python looks at the animal class, and we do have a function called eat in the animal class, so it prints out I'm hungry. And when we call speak, we do have that function in the dog class, so it prints that out. And when we call sleep, we don't have that function in the dog class, so Python looks at the animal class, and then we get that info or the printing self.name plus is sleeping. So we get that. So in this case, Rover is sleeping. So just like normal genetics, the child is not a perfect copy, right? I'm not a perfect copy of my parent. You're not a perfect copy of your parent. Yes, you have some similarities, but you build upon those similarities. You build upon those inherited genes, and you can have different characteristics. So yes, your parents could have blue eyes, but in a rare mutation, you could have a different color eyes, right? So it's all about building upon certain similar characteristics. So let's talk about extra methods. The animal class does not have a method called beg, but usually dogs beg, right? Dogs are known to beg. So in this case, we just print cute dog faces because that's what they do when they beg. But notice how this is not available in animal. So we've not defined a class called beg in animal. And this kind of makes sense, right? Because cats don't beg, they usually demand, and dogs beg. So it wouldn't make sense to have a beg function in animal because cats don't beg. So we will never call that beg function an animal, which means there's no point in including that function in the animal class. But since dogs do beg, we can implement that in that dog class itself. So now we're not implementing to animal, so cats do not have the function called beg, but dogs do because we've implemented in the dog class. So this is extra functionality to the dog class that the animal class doesn't have and the cat class doesn't have. So now let's talk about that order of lookups I talked about before. So basically it's pretty easy. Python just looks to the smallest scope to the largest scope. So if we have a certain method or class attribute inside our closest scope, which is the current class that the function was called on or what we're trying to get from, it looks at the current class. So it looks at the current methods, current class, then it goes to the superclass, and then if you have multiple superclasses, which you can, it looks there, and so on. So Python looks at the most closest class, and then it keeps looking higher and higher and higher. So that's basically it. So this is why when we call eat in this case, or if I go back, when I call eat, Python first looks at dog. Dog does not have eat, so it then goes to animal. But when I call speak, Python looks at speak in the dog class because that's the current class we're in. And we do have a speak, so it runs that. It does not bother looking at the speak in animal. So all you have to know, it just goes from the smallest to the largest scope. So let's talk about the constructor in inheritance. So we actually showed this in the previous screenshot, but we didn't talk about it. So in the dog class, we have our normal constructor, right? We have a normal def, init, self, and then we take in the parameter name. But inside that init method, we call animal.init. So we call the constructor of the superclass. Since animal does have an init method, if we look back, we do have an init method in animal that takes in the name and assigns self.name to be name. When we pass it in here, when we pass the name to the normal dog constructor, we also pass that name to the constructor of animal. So if I look back here, we pass in the name to the constructor of animal. So the syntax for calling the init method from a subclass is the class name .__init, and then you provide the parameters it requires. So obviously, since we're calling a function, we must match the exact parameter list in the superclass. So you can also use something called super. So this makes sense, right? Because animal is a superclass. So the super function allows you to access the superclass instance. So notice how, yes, dog is a class, but eventually we want to create an instance of the class, right? That's what we're creating classes. We want to create an instance of a class, usually. So when we create an instance of dog, behind the scenes, we're creating an instance of animal. So here, when we call super parentheses, we're talking about the instance of animal that's been created behind the scenes when we create an instance of dog. So that's really important to understand. It's an alternative way to do animal.__init in this case, but it automatically calls self. So notice there's a key difference in this case. This animal.__init is sort of like calling a static method, right? A static method does not take or needs the self to be explicitly declared, right? Because we have to pass in self. But here, when we call super parentheses, self is is automatically implied. So it's implied parameter self, because super parentheses is the instance of the object. And when we call a function of an instance, the self keyword is implied. Remember, the parameter is automatically provided by Python. So this is really important to understand the difference. If we're using super with parentheses, we do not provide self. If we're calling it like this, we do have to provide self. So that was it. This was a review of inheritance with Python. And the key things I would recommend reviewing is the super versus animal, or super versus superclass name.init, understanding how super is the instance of the object, while animal is just the class name, or whatever class name you choose, and understanding how you can override methods and also add your own functionality. So this is just like genetics in real life. The child has other characteristics that might not be present in the parent, and the parent might have characteristics that haven't been passed on to the child. But in this case, in programming, whatever parent you have, whatever class as you define as the parent class or the superclass, all of the instance variables, all of the functions, and basically everything of the superclass gets passed on to the subclass. But the dog or the subclass in this case can always have its extra functionality and characteristics. So that was the basics of inheritance with Python. We'll see you next week.